Okay, great, great. Well, it's good everyone is here. Thanks to all. We have quite a little bit to talk about, so let's go ahead and get started. Rao, are you ready for the technical update?
Yeah, I am. So we are continuing with the block merge work as well as with the hard fork one work. I explained last time that we switched the order to hard fork one first and then doing the block merge. In this week, we discovered one more issue with in block merge where what is now a per validator vault really probably needs to be something similar to a per deploy vault. And there is a design discussion for that going on right now. I think it's close to completion, and we will go ahead and start doing a small proof of concept of that and then start implementing that. But overall, that will take a little bit of work, but that's on the block merge side of things. The hard fork one, we're shooting for July 18th weekend still. And so where we are now, the situation appears like this, is that the first hard fork for balances and removing the slashed validator will go ahead. And then the second hard fork may be required for block merge. And the reason for that is most of the work for block merge, all the work is done other than this one issue that we need to deal with. So we don't want to necessarily delay the block merge until the second hard fork, because that's a longer, that takes it has a lot more items to it. So the second hard fork for block merge would take care of a couple of things. The one is this issue that I just talked about, which is the per validator vault fix. And the other one is the tree height fix that we talked about last time. Now, the tree height fix could go either in the first hard fork or could go in the block merge version. It doesn't matter because we already have that in. But this second one, the new issue that we discovered, the replacing the per validator vault with something like a per deploy vault to reduce dependencies and conflicts. That's something that we'll have to work on. And with that, the block merge can go as the second hard fork and block merge. Now, there would be the third hard fork with all the other changes that we originally contemplated for the second hard fork. So that would be the POS contract changes, rev vault changes, soft fork process, and a bunch of other items. So that is really what we're thinking about right now. This might change, but based on the information we have, this is kind of where we are. So hard fork one work is done. I think Will was reviewing the last set of things to make sure that we're ready to generate the report. And I'm not going to go through the bottom of this. Greg, I'm assuming, did you want to speak to the hardware aspects, or do you want? Yeah, I'll leave it up to you actually to do that. So this version today, because of the network problems, is a draft. I'm going to clean it up later and then do a final publishing. But for now, I wanted to publish it so that you have access to this. So that's kind of where we are. We're still on track to July 18th for the hard fork one, and then the block merge and the hard fork for block merge will be together. That should not be too far behind that. And then we will have the third hard fork, which is a little bit further down to with all the other changes, the POS and other changes. Are there any questions or comments on this?
I'll give some brain candy about the slicing and dicing of the vaults.
So rather than spend a lot of time on all the details about the vaults, what I'll do is just get to the very nub of the issue. So the issue is that the way the per validator vault was organized, more deploys were connected via the vault than we wanted. Meaning that if we reject a given deploy, we reject a bunch of deploys, which means we're getting less throughput for the system. We still couldn't get quite a bit of throughput, but we want to be able to maximize this. And I want to mention this because in general, this is going to become a programming methodology for people who are programming in Rolang against RChain. So the main point is that if you want more throughput in your code, you look for potential conflicts that don't have to be conflicts. So you look for uses of names that are overly aggressive in terms of the reuse of a given channel. If you can smear it out over multiple distinct channels, you have a better chance of reducing conflicts, which is very much the same principle as sharding against the database today. So if you can denormalize your data so that your data isn't, sitting in the same rows if you can optimize your data so that you can get independent access, then you can increase the total throughput of your application. So it's the same principle, but here we have a unit of conflict, which is the channel or name. And so the basic idea is that we want to have purses for each and every deploy that are independent, and then only aggregate those purses at key events, such as finalization. Right. So when you finalize, then you want to go ahead and aggregate the purses so that you know what you've accumulated on the validator. So hopefully go ahead.
Did you want to share your screen, or?
I will share the screen in just a moment.
Okay.
So the thing that I'm going to screen share is just in general, how do you take a list and spread it out over a bunch of channels in such a way that so the contents is all flattened and it's in a giant parallel construction, but you can still recover the structure of the list. That's at the heart of this purse aggregation idea. So hopefully that part is clear. If it's not clear, feel free to ask questions. Now I'll do a screen share. So I was giving you a little bit of background so that this code makes a little bit more sense. So it turns out that the code is actually a Rolang one-liner. I've written it in the one-liner style, and I've written it in the using the contract style. The one-liner style is a lot easier on the eyes from my perspective, but if you're used to Rolang syntax, here's the other style. And I've got a simple example. Let me increase the view here so it's a little easier to see. Hopefully that's viewable. Still fits on the single page. Okay, so the idea is if you have the empty list, so what we're going to do is we're going to translate a list into a giant par of isolated outputs. So each output is separate from all the others, and we're still going to be able to recover the structure of the list after we've sliced up the list. And by the way, this works not just for lists, but for any tree-like data structure. You can do exactly the same idea. You have to be a little bit more subtle, but not very much more subtle for any polynomial functor data type constructor. So the basic idea is that if you have the empty list, so remember we're given a channel. And we're gonna, if you have the empty list, then we're gonna output on the channel Z, the pair, which is nil, bottom, empty. It doesn't really matter. You just have to have a marker here, and false. And the false is gonna say whether or not to keep going. In other words, when it's false, you don't go any further. So this marks the end of the list. And notice that it could be that nil could be an element of the list, in which case you can't use this to mark the end of the list. You have to have a separate marker. All right, so now suppose that the list isn't empty. That means the list decomposes into a head and a rest, a head and a tail. So we're going to translate a non-empty list given the channel Z. So what we'll do is we'll output on the channel Z X, the pair X and true. True means keep going. There's potentially more here. You've got a tail. And that's going to be run in parallel with the translation of the rest of the list. But now we're not using Z anymore to translate. We're going to take, this is a process. In Rolang, you can always take the name of a process. So we're going to take the name of this process and use that for the translation of the rest of the list. So what's happening is we're nesting. Every time we recurse, we're going to nest. Right, so as an example, so if we want to translate the list 1, 2, 3, starting with Z, so we'll do one. I think, yeah, I flipped these around at the last minute. And I forgot to flip all these around. So let me just quickly do a search and replace. Where'd it go? Oh, well, never mind. I'll just do it by hand. True. Sorry about that. I thought it was nicer to flip it around. True. 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 True, 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 and false. Okay, there we go. So now, so the first element is going to be, so we're in this case right here. So the first element, we're going to output on Z the pair 1 and true, which means keep going. So, and now we're going to translate the rest of the list. So that's 2, 3. But we're translating that with this as our Z. That whole thing is our Z, right? So we're going to output 2 true on that. And so you can guess that this next whole thing is going to be our the output for the 3 value. And then the final one is going to be all of that, right? This whole thing, oops, stop. This whole thing, sometimes that mouse pad. Anyway, you get the idea. All from here to here is going to become the channel for empty list and false. So notice that there's no competition of the channels. All the channels are distinct. There's no updating the head element. And at the same time, you can detect when you've come to the end. So how would we so let me reverse this. This has to become false. And this is true. And then let's make this go instead of stop. Reads a little nicer. Okay, so how do we recover the list? Let's recover the list. So the contract takes our starting point, our seed, an accumulator, and a return channel. Now, if you can do more fancy stuff with the accumulator, I'm not going to bother with that. But here's the simplest thing. So on Z, we're going to get a pair, which is a value, and whether or not we should keep going. So on Z, the only thing that's sitting on Z is the value 1 and true. right? Okay, so we'll get that. And since true is not false, we're going to recurse. We're going to do drain again. And we're going to do drain with this one. That should be, sorry, true. So you do drain with this one, the accumulator where you've consed on the value to the accumulator, and R. So if we start our accumulator with the empty list, and R is just some channel, and Z is the initial channel that we use to encode the list, right? So now we're going to call drain with this. So what is this value? This value is 1 and true, right? So we're going to listen on this whole thing as a channel. So when we come back into drain, this highlighted thing is what's in for Z. There's only one thing that's sitting at that, and that's this one, right? So what we'll get here is 2 true. True is not false, so we go down here, right? And now this whole thing will be used for Z in the recursive call to Z to drain. So again, there's only one thing that that has that, right? And that's this one. So we'll get 3 true, right? And each time we recurse, we're adding it on to the end of the accumulator. So we'll get the list 1, 2, 3, and then when we finally have the empty list, we'll get empty and false. False will match this. So we'll send on R the list 1, 2, 3. So this shows you a very generic design pattern for Rolang that allows us to basically slice and dice the purses at a much finer grain than was currently considered. And this is actually a cool design pattern that you can use for all your data structures. With the circular ones, it becomes a little harder, a little more subtle, but for all your tree-like data structures, this will work, and it allows you to put your data in a flat par. So it's a giant key value table. And yet at the same time, you can reassemble the data back into the structure that you originally had it in. And that's the trick that we're using to slice and dice the purses so that we don't get conflicts, so that we can run more deployments during block merge. Any questions?
Now, this would allow you to process all your list elements in parallel, sort of?
Yep, that's correct. What it allows you to do is to store your list in a bunch of separate locations, right? Basically, we're making a list location for each element, right? So
And they're all in par.
And they're all in par. That's exactly right. But I don't lose information about how to reassemble the list.
Cool.
And, yeah.
Now, I presume you would have a new Z at the top there.
Yeah, you can do a new Z if you want. Or I just made it parametric in Z. Yeah.
Sir, could you explain this point when false is returned into the drain? Because each time it cases true and then drain, and then inside drain you pass true.
Yeah, right. So you know that what you got, if you're in this case, you know that what you got was true and some value. So you know that to assemble the next channel, you've got to use whatever channel you had together with the value together with true. You know that this must be the next place in the list.
Oh, I got that. Yeah. So basically, yeah, at that channel there will be false sitting.
So at the end of the list at that channel, when you use this to listen, what you'll get is a value and false.
Yeah,
and we know what that is.
Thanks. Yeah.
Sure.
Now it's clear.
Cool. Good. Then you can also convey it to Tomislav and Isaac. As we were Discord is just not a good place to explain this stuff. All right. Any other questions about this or any other material from the tech update?
Just a point of clarification with so each time that a value is drained, that's it's added to the previous values before in the assembly.
Yeah, that's what's happening here.
Okay, that's what I thought. Thank you.
Yeah, I mean, the thing that's really beautiful about this is that it shows a general design pattern that you can use for row calculus that is very different than the pi calculus. If you compare this to Milner's implementation of linked lists, while eye-opening because it shows you how you could scatter a linked list over the internet, right? So you could have the linked list live as a bunch of communications around the internet. It's more complicated. This one shows you how you could have a bunch of communications on the internet be a linked list, and it's done in one line. So there's clear value to the row calculus in terms of expressive power. All right, moving on. Daryl, you want to give the week in review?
Sure. Hey, everybody, here's the week in review for Thursday, July 1st to today, July 7th. Last Thursday, at the governance committee call, we discussed board recommendation for restitution of rev for rock deposited on DEX contracts. We also discussed funding to develop a crawler, and we discussed a proposal around purging inactive members involving implementing an annual membership fee. And we discussed prepping the nomination committee and outreach to candidates for the AGM in October. Also on Thursday, in the DApp Developer Working Group, they did a review of the June RGov rewards. On Friday at the Climate Coordination RCast, well, this one was actually from June 18th. We're a couple weeks ahead of the game with our RCast. So anyways, we spoke about the G7 summit, new oil and gas production around the world, and a new letter from financial asset managers owning $41 trillion, asking for governments to act more boldly on climate and to disclose long-term financial risks due to climate. Daryl, that's me, also discussed the West Coast drought, and Greg presented his ideas for a blockchain-based music collaboration game. So you can check that out at blog.arcchain.coop. On Saturday, the RGov smart contract call, they did live coding of group membership actions. On Monday, in the Casper stand-up, Greg covered a refinement of the OSLF construction for foundations of mathematics. They looked at a specific version of the element of predicate and how that works for set, multiset, and fuzzy set. Also on Monday, in the RDev member co-op planning, they tested RNode localhost install, and they discussed documentation deficiencies. Yesterday in the communications working group, we discussed hard fork announcements and communications for that. Apparently Tomislav is working on documentation and Raphael is working on web updates. We discussed the web press kit page. Thanks to Nora, Ian, and Raphael for your work on that. And it's available at rchain.coop/presskit. Jim brought up a situation where a potential developer tried to come on board and became frustrated because he couldn't find the help he was used to seeing from other crypto projects. So we discussed issues surrounding making RChain easier for devs to build on. Also yesterday in the DApp developer working group, they planned Shamir secret sharing for RGov private key backup. They also did some ballot actions, live coding. And then this morning in the RChain active member hangout, we discussed making a live chess game to demonstrate RChain's functionality. Jim brought up a video from Daniel Schmachtenberger and an initiative that he's part of called the Consilience Project. And here's a description from the About page of the Consilience Project. The Consilience Project is developing a body of social theory and analysis that explains and seeks solutions to the unique challenges we face today. It focuses on the deeper generator functions beneath the world's major problems, drawing on best of social theory while showing where existing theories and institutions are no longer adequate to fix the current problem landscape. The aim of the project is to help catalyze a cultural enlightenment that will develop a new set of shared values and capacities adequate to the needs of our time. End quote. And Greg, you might be interested to know that Jamie Wheel is listed as an advisor for this project. And Ian, you might also be interested to know that Tristan Harris is also an advisor on this project. So there's some amazing minds involved. So yeah, that brings us to right now.
Thank you, Daryl. Any questions for Daryl? The board had a great update from Steve Ross Talbot. The development with respect to the POC for the Arnold for the art collection is going very, very good. The Arnold, sorry, I keep saying the wrong word. The folks who run the art collection have put some serious skin in the game, and this could result in some big press and marketing for the co-op. More details on that in the Friday session. There was also a discussion about increasing the marketing solution. So we recognize that it is important to begin to expand the scope of our marketing efforts, and we're talking about sort of some of the best ways to do that. So if you have opinions about that, please come to the Friday meeting, and we'll talk about that in a lot more detail. Any questions about that? Right. Okay. So I will also mention that there is a New York artist who is the guy who did Tilted Axes, which got a lot of acclaim around the world. He's worked with lots of very famous musicians, including John Cage and Robert Fripp and many others. So Patrick Grant has been commissioned to do, but by another party, not RChain, to do a work on Rolang and the blockchain. So he's doing a piece of music that gives a musical interpretation of Rolang and the blockchain. And so he wanted some more examples of Rolang, and I provided him a more detailed view of the code that I wrote for the living world, which explores the boundary between computational agency and biological agency. For those who are interested, let me place in the chat a place where you can go get it, and I'll just give a quick view of that. So hang on a second. So if you would like to study that, that's there, and I'll do a quick screen share of that material. So hang on one second. Okay, so this has several different levels of interest. Some people may be aware that I gave a presentation at Ethereum's DevCon 3, where I presented Rolang, and I did a particular visualization of Rolang. So I used the same approach here. So that's completely algorithmic, and generated a visual version of this Rolang program. So if your eyes are more interested in diagrams, here's a diagram. So Patrick finds it easier to digest diagrams than syntax. So this was very helpful for him. If you're interested in the content, The syntax is easier for me to walk through. Essentially, the argument that I've made is that there are two basic considerations. There are many others, but two basic considerations that distinguish biological agency. One is metabolism, and the other is reproduction. And so I wrote down sort of the smallest Rowling program that I could think of that addresses metabolism and reproduction. Essentially, the Rowling program, which is designated life, so it's a contract called life. It has a place where it's connected to the environment where it may forage for food. That's S. It's got a channel for its internal metabolism. It's got a channel where it stores energy. It's got a channel where it signals that it should stop or die. And it's got some initial quantity of energy. So you might think of this as very much like a cell. So this is, you can think of this as in some respects, something like a cell. And so basically the idea is that we get some food. So we wait for some food from S. And so that's, you could imagine that the cell encounters some sugar in the fluid that it's living in. And so that sugar has some energy associated with it. So we extract the energy from the food, and if there's enough energy to keep going, so if erg is greater than enough, whatever enough is, then on metabolism, we output the energy we got. If it isn't enough, we die right away. And that little process there is running in parallel with a choice process or a select process, one of which is doing a join, and the other which is just looking for a signal on the death or apoptosis channel, right? So if we get so there's essentially a race going on here. If we get signal on the apoptosis, we just stop. But if we do get signal on the metabolism and the storage, right? So we've got some energy stored, and we've got some energy on the metabolism channel. Then we combine those two, and if that is sufficient to keep going, if that's sufficient, then we can create a new copy and of life. So this is the cell undergoing mitosis. And this one is the original organism. If we don't have enough energy to spawn, then the organism just keeps going. So that's the basic idea, and that is reflected here. By the way, this idea that metabolism is at the core of what is alive, metabolism and reproduction, is echoed in Eric Smith's recently published tome, The Nature and Origin of Life. I just found out about Eric Smith's book. A talk that he gave at the Santa Fe Institute, of which he is a fellow, on this work piqued my interest, and so I got his very large book. In which he goes through this, starting with an analysis of the solar system, from the solar system to the geochemistry and so on. But he makes a very similar point that what is conserved across all organisms is a biochemical cycle, which is at the heart of metabolism, and that you can in fact classify organisms in terms of whether the metabolism is reductive or oxidative, and whether or not the organism is an autotroph, means that it doesn't have to eat other organisms to survive, versus a heterotroph, so it does eat other organisms to survive. So that square is an interesting classification scheme for life, and this sort of computational analysis is very much in sync with that view. They have more details about the geochemistry and the biochemistry, but but there is a computational content in what they're saying that is very close to what's being said here. Any questions about that? All right. Thank you for letting me give you a little bit of brain candy today. Any other questions, comments, thoughts from the community? Great. Thank you all. And please stay safe, and we will see you on the other side.